Good morning, everybody. Yes, it's working. It's the last talk before lunch, and I don't want to steal any time from your lunch, so let's start quickly. I appreciate you're all here to join me at this presentation about Kubernetes native development workflows. And when I started to think about this subject, it basically began with one single command. So what are we looking at? We are looking at an OpenShift command line command. And as you probably know, OpenShift is built on top of Kubernetes. Kubernetes is the core of OpenShift. And when we execute this single command, there is a lot of happening in the background. It's the OC new app command, and we are referencing a Git repository. And when you execute this command, this will build your application, it will wrap it into a container, it will push it to a registry, it will deploy your application, it will create triggers and a lot of stuff. So that's awesome, right? With one single command. And I think it was about a year ago that I followed a course in OpenShift, and we really dive deep into this command, and we spent a lot of time to this command. And after the course, I asked myself a few questions. Is this the preferred workflow when we are working with containers and microservices? And the second question is, are there any other tools? And what are the pros and cons of all these tools? Well, of course there are. There are so many tools out there, and I'm not sure how you feel when you see a slide like this, but it's a bit overwhelming, at least a bit for me. There are so many tools out there. So after the course, I was looking for more overview and for more structure. And luckily for us, this structure is already provided by the Cloud Native Computing Foundation. And you are not supposed to read this slide because this is on the website from the Cloud Native Computing Foundation, the CNCF. And when you go to their website, you can see this with certain lanes. And there is a lane for software development, there's a lane for orchestration, for monitoring, for many, many technologies, and they already created the structure that I was looking for. But in this presentation, we are going to focus ourselves and to limit ourselves to the first lane about cloud native app development. And there are still a lot of tools to explore. So you can consider this presentation about my journey through the CNCF landscape and then specifically through the first lane, through the cloud native application development lane. And to be honest, I'm still learning, and I guess that's the life of every developer here in the room. I'm still learning, and I've not tested all the tools that I will mention in this presentation, but I think all the tools that we will discuss in this presentation do have a potential to be integrated in our development workflow. So, first, something about who I am. I'm Peter, and I do have more than 50 years. I have more than 15 years experience in the field of software development. I wanted to say software engineering, but after the talk of this morning, I don't want to do that. So I'm a Java developer at the text department, and I will tell you something more about Kubernetes native development workflows. So, what are we going to address in this presentation? First of all, we will take a look at our current development workflow and all the challenges that we have to deal with. Then thereafter, we need to talk about containers. When we will talk about Kubernetes, of course, it's inevitable to talk about containers as well. So we will take a look at container creation, and very briefly we will talk about orchestration, because this is all about development. Then thereafter, we will take a look at the OpenShift workflow. And then after this OpenShift workflow, we will also take a look at remote workflows when we are doing everything remotely. And then we will discuss the remote workflows. Maybe this is already a term that you already familiar with, but we will take a look at different types of remote workflows. And then we end with Quarkus. And it's not a coincidence that we will end with Quarkus because many technology, a kind of merge into Quarkus. Quarkus contains a lot of different workflows that you can use. So let's start at the beginning with our current development workflow and with the challenges that we face when we want to develop microservices. So I think this is again a familiar picture for most of you. Here we see at the left side our developer local inner loop. We see a very clear distinction between our inner loop and between our outer loop. In the inner loop, we write code, we build code, test code, deploy code. And then we push finally our source code to Bitbucket, for example, or another Git repository. And then our outer loop started and we'll create an artifact or an image or whatsoever. And I think this is fine. There's nothing wrong with this way of working. So how does this look in practice at the text department? Well, we have our Bitbucket repository, and we push our code to Bitbucket. We have Jenkins pipelines, and these Jenkins pipelines will create artifacts. Oh no. There again. And these Jenkins pipelines will create artifacts, and it will upload this to our Nexus repository, or it will deploy our applications to our application server on our IBM mainframe. But of course, at the text department, we are constantly trying to improve our way of working. So we are moving from Jenkins pipelines to Tekton, which is also a pipeline technology. But Tekton does run inside containers on our OpenShift cluster. So that's why Tekton will upload artifacts to, again, Nexus, but then it will deploy our applications on OpenShift, and we can still use Tekton to deploy our applications on the mainframe as well. And of course, in practice, it's always a bit more complicated. So we are not using one repository, we are using in a project multiple repositories, one for our app source code and one for our CI/CD pipeline. And then we have actually two Tekton pipelines, one for our app repository, which will build artifacts, build an image, and this pipeline will push it to our Harbor registry, and we have a separate CI/CD pipeline, and this will finally deploy our application on OpenShift. And we can do even a better job, because this second pipeline can be also Argo CD, who can listen to changes in our CI/CD repository, which is based on Kustomize, and which can deploy applications as well. So we already introduced a couple of new techniques in our way of working. So we're done, right? Well, maybe the point always is, it depends, because all these new techniques are all about deployment and not about development. So until now, we did apply a certain strategy, which is called the lift and shift strategy. So we wrap our monoliths into a container, and we push this container to our Harbor registry, and we deploy it on OpenShift. It's called the lift and shift strategy. But this has nothing to do with a new development workflow. So this is something that we have to discuss. How does this new workflow looks like, and do we need a new workflow? Well, if we take a look at our traditional inner development loop, then we have a very fast inner development loop. So it takes some seconds to commit our changes to our source repository, and that's okay, that's fine, it's a good loop. But when we are going to work with containers, we have a container development inner loop. And now we need to build containers, and we need to deploy containers, and we need to test with these containers also. So this will take minutes instead of seconds. So we have a problem here that we need to solve. So there are a few challenges more that we need to take a look at. So there's a developer here who said, oh, when we are going to work with microservices, there's so much configuration there. And another developer said, debugging is a pain. How can we debug an application that's running inside a container? How should we do this compared to our traditional way of working? And another developer says, there are so many moving parts. When we are working with microservices, most of the time we are working with multiple microservices. And there are so many moving parts. How can we manage this? And another one says, I spend so much time outside of the code. I really want to focus on the code alone and not on all the stuff outside. So these are all challenges that we need to deal with when working with containers. And another challenge is, most of the time we have multiple microservices. And this was one of the pictures that we've seen before in the first presentation. It's about Netflix. And Netflix has more than 500 microservices. Should we run them all locally on our local developed machine? That's not doable. Maybe we should mock them, mocking techniques. And of course, mocking is great. But if you have more than 500 services, that's not a great job. And if you have 5 or 10 microservices, that's doable. But if you have more than 10 or 20 or 30, this becomes more a problem. So how can we solve all these problems? Let's take a look at the more inner development loops. One of the things how we can solve this problem is just don't work with containers in your inner development loop. So this is exactly the traditional way of working, or the no container approach in your inner development loop. So containers are created in the outer loop, and we have no containers in our inner loop. And we have to keep in mind, we have to be aware of the fact that in this case, development doesn't match production. And when we do a commit, we can basically translate every commit with, it works on my machine, and go for it. And is this bad? Well, maybe not. It's pretty simple. It's our traditional way of working. Containers are created in the outer loop, and this could work. This could work. But you have to be aware of the fact that there can be failures in production because it doesn't match our development environment. So there is another approach as well, where we add an additional step in our inner development loop, the containerized step. So when we add this step, we create containers in our inner development loop that we have already seen before. Then our inner loop becomes really slow. And we still have the works on my machine problem. And I learned on DevOps this year that instead of having the works on my machine problem, you could better aim for the fails on my machine. Then you can solve these problems that you won't have in production. So this might not be the best solution with respect to our inner development loop. But there is another one, which is called the hot reloading approach. And we will see different examples during this presentation about hot loading. We will react to changes. We have a running app. We do something in our integrated development environment, and they are immediately pushed to our container. So this might be something. We have a faster inner loop, so all problems solved, right? Well, maybe, not yet. So let's start at the very first beginning about containers, about container creation, and about orchestration. So there are many, many tools that we can use to create containers. And I think the most familiar one, if you are a bit used to creating containers, is Docker. But there are multiple of them, like Podman, and more advanced ones, like the source to image or the Java image builder from Google. And we won't go through every detail from in all these tools. We will pick a few of them and see how we can create containers. And when we talk about containers, we are actually talking about OCI appliant containers. OCI stands for the Open Container Initiative. And this specification states that we need a container file. Most of you think I know about the Docker files, but we can better call them container file. It's a more general name, and based on this file, we can create containers with Docker or Podman. And you have to be aware of the fact that the default user in Docker is root, as opposed to Podman, which will create rootless containers. And with Docker, we need to install a daemon to work with Docker containers, as opposed to Podman, where you don't need a daemon, you can just install it and use it. And it's very easy, of course, like an example here, to run a Docker or a Podman container. Another approach to create a container is with build packs. And build pack itself is actually a specification with multiple implementations. So one of this implementation is the tool pack. And for us, this is still work in progress. We haven't used it, and we are still exploring the features of this tool. But I kind of like it because of the features that it contains. And one of the tools is Pack, which uses a builder image to build your application. So we don't need a JDK or Maven or something else. It will detect the programming language and it will build your application. It will wrap it into a container. And of course, this is not really distinguishing from Docker or Podman. But one of the other possibilities is the rebase functionality with build pack. And this is pretty something cool, because when you create a container, your container is built from different layers. And it's also always built on a base image. So suppose we have a version 1 base image and there are some vulnerabilities. These vulnerabilities we want to solve, right? So what we can do is just rebase our image instead of creating a lot of new containers based on this base image. So this is something that we want to integrate in our development workflow. Well, when you are using pack as an implementation of the build pack specification, this is based on Docker. But there are also other implementations which are not based on the Docker daemon. For example, Tekton. Tekton also implements the build spec specification, and it provides us with different tasks that we can use in our Tekton pipeline to create the containers. And a more advanced approach to create our containers is the source to image approach, which also uses a builder image to build our container. Where Docker and Podman and build packs runs on your own local machine, this will run on an OpenShift cluster. And with this, we only need to create a resource, the build config resource. And this is an OpenShift resource where we need to define an input, of course, which is most of the time a Git repository. We need to define an output, which is most of the time an image in a registry. We can define triggers as well, so it will respond to changes. For example, when our image changes or there's a code change. So this is another way, a more advanced approach to create our container. But wait a minute, we have already seen Tekton, and now we have the build config. These are both ways to create containers, but what's the difference? Why should I use a build config instead of Tekton? Well, if you really want to quickly build your application, then the build config might be a very good approach. But if you want to create more complex pipelines, then Tekton may be better, because everything that you can do with build config is also possible with Tekton. So something briefly about orchestration, because we really want to talk about the development workflows, but something about orchestration if you want to run your Docker. I think Docker Compose is the most familiar one. It's pretty feature rich. You define your services in a Docker Compose file. You just run Docker Compose up and there you are. Your services are running in Dockers, in containers. And the counterpart of Docker Compose is the Podman Compose, which is obviously based on Podman. It's less feature-rich than the Docker Compose, but what might be a better option is to use the Podman Play Kube. Because when we want to deploy our application on Kubernetes, or in our case on OpenShift, we need to create a Kubernetes manifest file, the YAML files. And it would be great when we can test this YAML files already on our local machine instead of just pushing it to your cluster and see that it will have a failure for some reason. So with this Podman Play Kube, you can just run your Kubernetes manifest file on your local machine. It can create pods and whatsoever, and you can test them very well. Well, another option is using Minishift or Minikube on your local machine. We have not a really good experience with Minishift because it needs a lot of memory on your local machine and it can even cause to crash your laptop. So our experience is not that good with Minishift. Maybe you have other experiences, but let's go to the next kind of workflow, the OpenShift workflow. And we have already seen something about this OpenShift workflow on the first slide of my presentation. It was about the OC new app functionality. And what's great about this kind of workflow is that you just need to reference a Git repository and it will do everything for you. It recognizes your programming language. If you have a Docker file, it can detect that you can build your application with this Docker file. And at the first time when you run this command, you only need to link your SSH key pair to the builder account in OpenShift. That's the only thing that you need to do at first, and then it will do the rest for you. Well, how does this look like in a little bit more detail? It will clone your code. It will use the build config to build your application, and it will finally push the result to our internal registry. But then thereafter, it will create also a deployment resource. So here is a list of all the resources that it will create for you. It will even create your service and route resources so your application can be reached from the outside. So this can all be done with one single command. And of course, there are plenty of options to configure this command. You can specify your own builder image. If you have some PHP code, for example, you can specify here that it needs to use the image builder for PHP, or it can define a context there, or another branch, or you can have another strategy like Docker. So there are many possibilities with this OpenShift workflow. But of course, there are other workflows as well that we need to explore, because we can also do everything remotely. And what does this mean, everything remotely? Even our integrated development environment, in IntelliJ, for example, can we run outside of our local machine, and can we use Coder or Gitpod or the Eclipse.js project to create a container which contains your integrated development environment. So this is something that we need to explore at the text department. We already have seen some presentations about it, and we are still thinking about it, if we should use this or not. But this is one of the possibilities by using the OpenShift dev spaces, which is built on top of Eclipse.js. And this will basically provide us the license management, and it will provide us with different custom resources, the dev space operator and the dev workspace based on universal developer images. So this is something how we can run everything remotely, even our integrated development environment and test containers and the whole stuff, so not on your local machine. And this is still something, again, that we need to explore at the tax department. So up to now, to sum up a bit, what we have seen so far is that we've seen traditional workflows. And we have seen how we can create containers, how to orchestrate them. And we've seen something about OpenShift workflows and something about remote workflows. So when we zoom out a bit and take a look at the inner development loop, we can divide all these methods into two different categories. The first one are the local workflows, and the other one are the remote workflows. But the question arises, is there something in between, a more smarter cooperation between our local workflow and between our remote environment? Well, yes, there is. There exists the remote workflows, which is a composition of the local plus remote, of course, which stands for remote workflow. So we need to explore a bit about this remote workflows. And we have a couple of approaches right here. The first approach is that we develop everything locally, but we run our application remotely. And every time when there is a code change, we sync the changes with our remote running application. The other approach is a bit different. We develop and run everything locally, but we will route traffic meant for our service running on a Kubernetes cluster, and we intercept this traffic and we send it to our local machine for testing purposes. And of course, we will see different examples of the different approaches. So, talking about different tools, the remote development tools, there are many of them, of course, and I think it's always good to take a look at what are the big tech parties doing with respect to the remote workflows. Well, one of them is Scaffold, for example, which is from Google. Another one is Draft, which is from Microsoft. Of course, we cannot go in detail through every different tools here, and we will take a look at Quarkus, of course, but now we will first take a look about the OpenShift do command. And I like this command. It's one of my favorite tools because of its simplicity. We have two commands that we basically need. We need the odo init and the odo dev command. And there are a lot of tools who have this dev mode, and we will see more examples of this. But what odo init will do, it will detect your programming language again. It will download the dev file from the registry. Of course, you can create your own dev file as well, and that's what we are doing at the tax department because we can add custom properties. But when you have your dev file, you only need to run odo dev. And this will create your application on the cluster. It will deploy and run your application, and it will listen to your local changes. Thus, when there is a code change, it will immediately push your change to the remote running application. And what I especially like about this OpenShift do command is that you don't need to create any YAML files. I'm not against creating YAML files. It's not that bad. But with this tool, you don't need to create any YAML files as opposed to other tools. You just need to execute these two commands, odo init and odo dev, and it will automatically do the port forwarding for you. So most of the time you have your application port and you have your debugging port. It will automatically create local ports for you so you can attach them to your integrated development environment. So let's continue with the next tool. It's from Google, of course, Scaffold, and it's a kind of client-side tool, a CI/CD client-side tool. And again, it really looks like what we can do with odo as well. But Scaffold has a nice feature because it will build your container in the background. When there is a change in your code, it will locally build your container. But this will not take a lot of time because it will do this really, really smart. It won't create the whole container in one step, it will only adjust the layers which are changed. And this is why Scaffold is really, really fast to recreate your container. One of the downsides of this too is that you need to create your Kubernetes manifest file, but of course you can use another tool which is called Decorate for this. You just need to add the dependency to your PAM file, the Decorate dependency, and then this will create the manifest for you. Well, these were examples of the first approach. We call this the sync approach. But there are also examples of the second approach, and we call this the route approach. With telepresence, you can let your local developer machine act as part of your remote cluster, whether it's an OpenShift or a Kubernetes cluster. And this is often used together with tools like Scaffold or any other dev mode tool. So the telepresence is really to test your application with real life data. So how does this look in practice? Well, we have here the telepresence with two components. We need a cluster side component to intercept the traffic going to our remote running microservice. We want to intercept this traffic and send it to our locally running microservices. And we need a local traffic agent at our local developer machine, so we can call remote services. Well, how does this look in practice? We have two different commands. We need to install, of course, the telepresence 2, and then we can make use of the telepresence connect, which will basically install the cluster side traffic manager, and we need the telepresence intercept. And this will intercept the traffic from the remote cluster and send it to our local machine. Well, how does this look in practice? We have three different services. We have the first service, we have the caller service and the call me service, and we are developing the caller service at our local machine. And we are ready to test our microservice on our local machine. And here we intercept the traffic from the first service to the caller service, and we send it to our local machine. And the caller service will call another service which is running remotely. And this can all be done with telepresence. Well, another tool that we can use as well instead of telepresence is Scupper. You can really achieve the same result with Scupper instead of using telepresence. And with Scupper you can connect different Kubernetes clusters together. And what's nice about Scupper is that you can also install it on your local machine, so your local machine becomes part of all the connected Kubernetes cluster. And then you can achieve the same result with Scupper. Well, finally, let's talk a bit about Quarkus, because we've seen different examples of different remote workflows. And personally, I'm a big fan of Quarkus, because with this Quarkus framework, you can do a lot of things that we've seen before in the presentation, but with different tools. But now we can do this all together with one framework. So what is Quarkus? I think it's a familiar framework for most of you. It's the Kubernetes native Java development stack. And what's great about Quarkus is that it's built on standards. It's built on the microprofile. It's an implementation of the microprofile specification. And of course, it's built on Jakarta. And Quarkus is really focusing on developer joy. And I think they are doing a really good job with respect to this developer joy. When we take a look at the features of Quarkus, we have the Quarkus dev mode, and we have seen this before in other tools, but this Quarkus dev mode, with this dev mode, no containers are involved. It's the live coding mode. So you run your application without containers on your local machine, and when there are code changes, Quarkus will pick this up and refresh your application. Another cool thing is the continuous testing. When you change your code, it will see if there are corresponding tests, and it will run your tests if your code changes. And what I like about Quarkus especially is the dev UI mode. You can see a lot of the internal workings of your application here in this dev UI mode. Because you can see, for example, which beans you have injected with your CDI, or if you're using OpenAPI or even Keycloak, you can reach them all here via the dev UI mode. And Quarkus also supports different remote workflows, like the Quarkus remote dev mode. And we will see that in a minute. So another thing that's great about Quarkus is the dev services, and we have been talking a lot during different conferences, also in DevVox this year, about test containers. And this is also supported in Quarkus with the dev services. I do have some experience with the Keycloak dev service, and I'm not sure if you have ever configured Keycloak, but that can be really cumbersome. So what you can do here is that you just inject a dependency in your POM, the OpenID Connect in your POM file, and Quarkus will detect that you are using OpenID Connect and that you will probably need a Keycloak instance. And it will start this Keycloak instance for you. It will spin it up and it's there just for you without any coding, without manual configuration or integration. It's just there for you, and your Quarkus application will reference this Keycloak instance. And of course, all for testing purposes, not for production, of course, but as a developer, you just need this when you are working, for example, with OpenID Connect. But there are other possibilities as well, like different databases, and you can even spin up a Kubernetes cluster in a container when you are working with Kubernetes locally. So there are different ways to deploy your application in OpenShift, and this is one of them. With OpenShift, with Quarkus, you can use the Quarkus OpenShift dependency, and when you add this dependency, it's very easy to deploy your application to a OpenShift cluster, like we did with the OC new app, but now we can do this with Quarkus without any additional tooling. So we have different deploy strategies, like the Docker strategy, if you have a Docker file, or the source to image strategy. So how does this look like? We only need to run this command right here. We are using Maven here, and we are using Maven install to create our artifact. And with this additional property, with the quarkus.openshift.deploy is equal to true property, we can deploy our application to OpenShift. And what is it doing? Well, it will actually create all the resources that we can create with OC new app as well. Well, are there any differences? Yes, there are. With this Quarkus OpenShift dependency, we can only use the S2I binary build. So we need to create an artifact ourselves, and that is actually what we are doing with Maven install. And then it will wrap it into a container and push it to the cluster. But with OC new app, this also supports the S2I source build, because this can reference a Git repository. So there are some differences, but I think it's a quite convenient way in Quarkus to deploy your application, just by adding a dependency to your POM, nothing else. And we have, of course, the Quarkus remote development, like we have mentioned before. This is an example of the first approach of our remote workflows. And the only thing that we need to do is to create a mutable YAR. And we can create this mutable YAR by just defining a property in your file, the Quarkus package type. And we configure this to mutable YAR, and we push our container, we deploy our container on OpenShift, for example, and we just call the Maven Quarkus ..remote dev command. And this is an example of the first approach. It will sync all the code changes that we've made locally to our remote running application. But we can do more with Quarkus, because we have also an example of the second approach, and we call this the route remote approach. And we can do this with a combination of Quarkus and JCube. JCube is from Eclipse, and with this combination, we can create the second remote workflow. So how does this work? With Eclipse JCube itself, we can also deploy our application to OpenShift very easily with the OC build command or the OC resource and OC resource. But we can already do this with Quarkus as well. But the nice feature here is all about the Eclipse JCube remote development. So where we have other tools like telepresence and like Scupper, where we need to install other tools to create the second approach remote workflow, now we can just do this by adding a plugin, the JCube plugin, to our POM. And we can configure our plugin in our POM again, and we can define our remote running services, and we can define our local running microservices just by configuring our POM, and then we will run the remote dev mode from the Eclipse JCube remote development. So this is another example of the different remote workflows inside Quarkus, and that's why I am a big fan of Quarkus, because we just need this framework instead of using a lot of other tools. So let's go to the summary of this presentation. We have seen many different workflows, and one of them were the remote workflows. And we had seen the sync approach, where we've seen 3 different tools, like the OpenShift Do, the scaffold, and the Quarkus remote development way of working. But we've also seen the second approach, where we route traffic to our local machine, and we've seen a combination of scaffold and telepresence. We've seen a bit about Scupper, and we have, last but not least, seen the Quarkus in combination with JCube. So this was my presentation about my journey through the CNCF landscape. But I'm also interested in your lessons learned and your tips and tricks to me. So I'm also interested in your stories. So if you have any questions for me or any remarks for me, you can ask them now, but I am also here at the conference all day, or you can meet me online, of course. So thank you for your attention.